All right, so here's a vector D. And so the convention is you measure the angle to use these formulas. So when you're finding the components, and when you use these formulas, in these formulas, the angle is always measured counterclockwise from the x-axis. Okay. Now, if you don't measure the angle, so the counterclockwise angle, this would be, that's 143. So 143 degrees, and if you put this in there, that'll give you the right sign and all that. But what you want to be able to do is the following. So there's this angle, D is 37 degrees. Okay. There's the y component, and there's the x component. Now for a right angle triangle, you know that this side is hypotenuse times sine of that angle. The adjacent side, the length of the adjacent side is the hypotenuse times cosine 37. Okay. All right, so what I'm going to do is, since I've run out of space here, okay, so dx is d cosine 143. If you take the angle from the x-axis, that'll give you the sign automatically. Or it's equal to negative d cosine 37. See, d cosine 37, if the angle is acute, it's only giving you the magnitude of this side. And since it was pointing in the negative direction, you put the negative sign by hand. Okay, so this is a useful thing to do. You want to get used to this. dy is d sine 143. So if you take the angle from the x-axis, the sine is taken care of automatically, but and d was 20, so this is all right. And then we have to find f. All right, so here is fx, that's negative. Okay, so 20 cosine 30, and here is fy, which is also negative, 20 sine 30. So fx is minus 20 cosine 30, and fy is minus 20 sine 30. All right, so now we have the components. So let me gather all that information. A is 8.7 and 5. What we have found is A is 8.7i plus 5j. D is minus 16 and 12, minus 16i plus 12j. F is minus 17.3. Okay, and now you can find anything you want. Okay, so this is the first thing you have to do. You have to find the components, and now see in the problem they ask you to do a minus 4d plus 2f. Okay, so all that becomes okay. So this will become ax is 8 point. So I'll write it in two steps. Ax minus 4dx plus 2fx I plus ay minus 4dy plus 2fy j. All right. So again, you saw that to do any algebra with vectors, well, so the point is to do algebra with vectors, first you have to find the components of the vector. Okay? This is a problem where okay, I have 24 minutes, so maybe I won't do this again. You have to just draw a whole bunch of vectors and then add them. Okay, how do you add vectors? You find the components and then add them. Okay, so I'll draw a couple of diagrams. In an attempt to escape a desert island, a castaway builds a raft and sets out to sea. The wind shifts a great deal during the day and he is blown along the following direction: 2.5 kilometers, 45 degrees north of west. So here's the first displacement, 2.5 kilometers, 45 degrees. Then the second is then then 4.7 kilometers and 60 degrees south of east. So the second displacement, okay, I'll draw it as a separate line. 4.7 kilometers, 60 degrees. Okay. So call this A, B, and then you would add up all those vectors. Okay. So you have a whole bunch of vectors, and I'm not going to do that. Okay. Do you guys understand what to do? Okay. Everybody? All right. Okay, so I'll do this problem. So they gave you A and B, and they want you to find the displacement, or they want you to find this vector and the magnitude of this vector. Okay, so So 6 minus 2, 4i, minus 8 plus 3 is minus 5j, and 8 minus 7 is 1 plus k. And the magnitude of d is dx squared plus dy squared plus dz. Sixteen, 25, 41, 42. Yeah. Okay, if you have two unknowns, how many equations do you need to solve it? I'm sorry? If you have two unknowns, how many equations do you need to solve it? Two. Okay, so here's a problem. They give you the vector d, they give you the vector b, and they give you the vector a. So ad plus b plus a equal to 0. And they want you to find the constants a and b. That's two unknowns. Looks like there's one equation. Okay, so all these vectors are two-dimensional vectors. So if a two-dimensional vector, this is not really one equation. What this is axi plus ayj equal to bxi plus byj. What this is really saying is ax equal to bx, ay equal to by. So that's really two equations. So this 0 is not the scalar 0. It's the 0 vector. What this is 0i plus 0j. Okay? So what this is really two equations. So this is a dx plus b bx plus ax I plus a dy plus b by plus ay equal to 0i plus 0j. And what this means is, for this vector to equal the 0 vector, the x component has to be 0 and the y component has to be 0. Okay? So it's really those two equations. So what we're saying is, see, now you have two equations and you can solve them. Okay? All right, so I'm going to write them down. So a dx is 6a, and bx is minus 8b plus 26 equal to 0. A dy minus 8a plus by is 3b, and ay is 19. So there was the x component, there was the y component. Okay? And now you can solve it. You have two equations and two unknowns. Okay, so if those were three-dimensional vectors, you could have given three unknowns. Okay? Any questions on that before we move on?
So this isn't the final answer that it's asking for, this is how to get the information for the final answer?
Yeah, now solve for a and b. Yep.
And this is essentially the matrices we'll be working with.
I'm sorry?
This is essentially the matrices we'll be working with, and matrix.
What?
Multiple systems of equations.
You can solve them using determinants if that's what you're meaning. Do you want me to solve that? Anybody want me to solve that? Or you guys got it? I'm sorry?
I don't think it would hurt to solve it and see how it's done.
All right. All right, so the first thing we'll do is 6a minus 8b equal to minus 26, minus 8a plus 3b equal to minus 19. And again, in general, just about every technique that you learn is you have three equations, three unknowns. You'll reduce that to, well, this is two equations and two unknowns. And then you reduce it to one equation and one unknown, okay, and then you solve it. All right, so what we can do this, here's 24 is a common factor, so we'll multiply this by 4 and this equation by 3. So that's 24a minus 32b, and 24 times that is 104. Minus 24a plus 9b minus 57. You add them and this is, you get, so minus 23b minus 161. Okay, and then you plug it back and get it. Okay, so when you see a problem like this, find the angle between vectors. Generally, you use the dot product, okay? So we'll do this one, okay? Those are two-dimensional, so let's do this three-dimensional vector, okay? And you see these displacement or position vectors, they both have dimensions of meters. Okay, so okay, so let's say this is B, this is D, and they're asking you to find this angle theta. Okay. So B dot D, the scalar product, by the way, this is commutative. You could have done D dot B, you would get the same answer. Okay. You have two definitions for this. Here's the definition in terms of components. But this guy doesn't have the angle explicitly in it, in this formula. Here's in terms of the length. This guy has the angle. All right, so this is what you want to find. Well, you'd have to independently find the length. You'd have to find the length of D. And this you can find from the components. So you know this since you know the components. You can find this since you know the components. And then you can solve for theta. Okay. So cosine theta is bx dx plus by dy plus bz dz okay. All right, so bx dx is minus 4, bx dx is minus 4 minus 12 and 2 times 1 is 2 plus 2. Okay, so that's minus 16 minus 14. And then magnitude of b is minus 2 square plus 3 square plus 2 square. That's 4, 8, 17. The length of D is 2 square plus minus 4 square plus 1 square. 16, 20, 21. Okay. So cosine theta is b dot dbx dx. Okay, so minus 14 divided by these two guys. Minus 14 divided by root of 6. Yeah. So cosine of this negative number is an obtuse angle. Okay, so I'll do a cross product and I'll do one of these guys, okay? So so find the cross product of A cross C. Let's pick a three-dimensional vectors. So here is a three-dimensional vector, and here's another three-dimensional vector. Okay, these two guys. So we are finding A cross C. Is A cross C the same as C cross A?
No.
Okay, so C cross A is negative of A cross C, okay? All right, this is equal to, the X component is, okay, so again, I'll draw this. I'll write down the formula. X component is AYCZ, okay? AYCZ minus AZCY plus the Y component is AZCX. Plus the Z component is AXCY. Okay. So let's do this. So the X component, so here's the X component is AYCZ. So there's the minor, okay? Minus that minor, okay? So minus 40 minus 4, minus 44I. The Y component is AZCX. So here's the minor. AZ, that's 3 minus 20. So minus 17J. The Z component is AX. This is the minor, 8 minus a minus 12. That's 20. Okay. Yeah. So there's the cross product. And go home and review it and practice on the rest other cross products. Okay? I'll do one more problem, this one. All right, so this is the three-dimensional vector. How many numbers do you need to specify it? 3, okay? The polite numbers would be to give you magnitude and 2 angles, or these guys. But you could give any combination of 3 numbers, okay? So in this problem, you see, find the scalar components of the three-dimensional vectors. What they've given you is, they've given you the GY, they have given you this, okay? So let's see. They have given you this, they have given you this, and they haven't given you that. So they have given you those 3 numbers. This is theta, this is phi, and they've given you GY. Okay. And so they want you to find GX and GZ. Okay, so well, we'll end up finding G as well. Okay, so you see from this diagram, GZ is G cosine 60. GY is G, okay, so this guy is G sine 60. And that guy is equal to this guy. And this guy is sine 45 of this guy. Okay, so GY, which is equal to 10, is equal to G sine 60. G sine 60 is this guy, which is that guy, times sine 45. So this should really be GY. So G, the magnitude of G is 10 divided by sine 60 sine 45. So the length of vector G is that, and so now you can find GY. Oh well, GY is 10. Okay, GY is 10 is given. Okay, so GZ is 16.3 cosine 60. Okay, so GX, which is that guy, is this guy, which is equal to that. So G sine 60 cosine 45. G sine 60 cosine 45. And since this is an isosceles triangle, GX has to equal GY, which is, and this should work out to be equal to 10. Okay. All right, guys.